Okay, so the formula for this thing is x naught sine omega t, right? So that means this must be our x naught, this must be our omega, right? Okay, so what is its maximum velocity? Well, what's its position? So they want us to plug the numbers in, right? So literally you must be in radians. Radians. Okay, so put your calculator in radians, go second mode or mode, and then go down to radians and hit enter, right? And then at t is 156.7 seconds. We're just going to plug that in, right? So x equals 0.45 sine of 45.1. That's radians per second, right? This is meters. Okay, times 156.7 seconds, right? Equals, and I'm just going to let my calculator do this, right? So 0.45 times sine of parentheses 45.1 times 156.7. Okay, did I do that right? Yes, I did. And the answer is negative 0.44. Well, this is a cool number. Wow, 444. It's 1, 2, 3, 4, 5 fours, and then it busts out, you know, does a little tap dance or something like that. But that's meters. Okay, that's what my calculator says, right? What is its speed when it's 0.34 meters from equilibrium? V is plus or minus omega. That's an omega. Square root of x naught squared minus x squared, right? So that's going to be, do we have omega? Yeah, it's 45.1. Okay, so V is 45.1 plus or minus this, right? Okay, this is rads per second, right, times the square root of, the amplitude is 0.45 squared minus 0.34, right? So let's see, 45.1 times the square root of 0.45 squared minus 0.34 squared. And I get 13.29 meters per second. Yay. Okay, so let's see. C. That's interesting. I just answered C. Why did I do that? Anyway, this is C that I just answered. And then let's answer B, right? Okay. So B says, what is its maximum velocity, right? And of course that's going to be, we're going to use this, right? Omega plus or minus omega, right? Times the square root of x naught squared minus x squared, right? So maximum velocity is when this guy's 0, right? So that ends up being omega x naught, right? And so this is easy. I just multiply the omega, which is 45.1 times 0.45, right? So 45.1, I'm doing omega times x naught, right? This is radians per second times 0.45. 0 meters, right? Okay. Okay, so let's go 45.1 times 0.45. And I get 20.295 meters per second. So that's our maximum velocity. So this is our answer to A. Here's C. Apparently B. I don't believe in doing things in the right order, right? Okay. And then D says, what's the equation for its velocity? Well, that's easy. Here's our V naught, right? That's V naught, right? Okay. And if it's sine, then of course the velocity is cosine, right? So D, what's the equation for its velocity? V equals V naught cos omega t, right? So there's omega. That's easy, right? So it's going to be V equals, and then the maximum velocity is 20.295 meters per second, right, times cos of 45.1 times t. Okay, So there it is with all the proper sig figs or whatever, right? I'm going to use this though to calculate my value. Okay, so then it says at 156.7, so we're supposed to plug in the numbers for that, right? So V is equal to 20.295 cos 45.1 times 156.7. Okay, so times cos parenthesis 45.1 times 156.7. So we pick some random time in the future, right? And we get that the velocity is positive 3.179. Oh, that's interesting. Okay. So it is, yeah. Okay. That's interesting. So this is our meters per second, right? So what we've got is that the position is down minus 0.444. The maximum it's down is ever is 0.45, right? Okay. So it must be that our position looks like this. We've got to go up and we go down, right, like that. And we were just at the maximum, but now we're like here, we're headed back up, right? Okay. And notice that our velocity is positive, so we're actually trending this way, right? We're moving toward zero from the negative side. Okay. More than you wanted to know, but there it is.